Hi, we're looking at new answers, lesson number 9. And the question they present is, does radiometric dating prove the Earth is old? The radiometric dating is the primary dating method scientists use for determining the age of the Earth. Okay, it's radioisotope dating. The proponents of evolution publicize radioisotope dating as reliable and consistent every time. They use radioactive dating. Scientists have determined that the Earth is roughly 4.5 billion years old. The Earth is commonly regarded by these evolutionists as 4.5 to 4.6 billion years old. So the question then is, what is radioisotope dating? Its definition is this: the process of estimating the ages of rocks from the decay of radioactive elements in them. Some examples of the radioactive uranium decays into stable element lead. Potassium decays into argon. So how does it work? Commonly used to date igneous rocks, okay? So it's used mostly to date igneous rocks. These are rocks which form when hot, molten material ends, it cools and solidifies, okay? Example is granite and basalt. Then we have sedimentary rocks. And sedimentary rocks contain most of the world's fossils. It's not commonly used in radioisotope dating. And some examples of those are sandstone, shale, and limestone. Radioisotope dating, the dating clock starts when a rock cools, okay? And here's the assumption, a couple assumptions, right? The assumption is intense heat forces any gaseous daughter elements to escape, like argon. So once cool, no more atoms can escape, and any daughter element found are the results of the radioactive decay. The dating process then requires measuring how much daughter element is in a rock sample and knowing the decay rate. Okay, makes sense. So there's a couple types of decay that we have to talk about. Alpha decay, which is when a radioactive decay causes an atom to lose 2 protons and 2 neutrons. And then there's beta decay. Okay, and under beta decay, there's a couple different types. Beta minus decay, which is when an electron is lost and a neutron is converted into a proton. Or a beta plus decay, when an electron is added and a proton is converted into a neutron. A little confusing, but stay with me, okay? A couple more definitions real quick. Atomic mass is the heaviness of an atom which when compared to hydrogen, which is assigned the value of 1. And then we have half-life. The half-life is the length of time it takes half of the remaining atoms of a radioactive parent element to decay. Some assumptions and some facts, okay? 3 critical assumptions. 1 is that the initial conditions of the rock sample are accurately known. 2, the amount of parent or daughter elements in a sample has not been altered by a process other than radioactive decay. And 3, the decay rate, or half-life, of the parent isotope has remained constant since the rock was formed. So let's look at what the book calls an hourglass illustration, okay? And ultimately what they're saying is, if you take an hourglass filled with sand, and you walk in and it's already draining sand out of it, what do you know? Well, was there any sand at the bottom when the hourglass was first turned over? That's the initial conditions. Has any sand been added or taken out of the hourglass? Has the sand always been falling at a constant rate? Did somebody tip it back over? Was it, shaking at different things, okay? And so when you look at that, those, become extremely important. The initial conditions. Has anything or anybody affected it? And has there always been a constant rate? These are the facts. We know radioisotope dating does not always accurate, okay? There's a rate group, which is the radioisotope and the age of the Earth group that has scientists basically got together to study this phenomenon. Rock samples from newly framed 1986 lava dome was dated wrong. It shows significant argon was present when the rock solidified. So that makes assumption number 1 false. Then you have the isocon dating, which analyzes 4 or more samples of the same rock. Another form of dating, which often has varying results. A single sample and an isocon dating frequently do not agree. Two conclusions of this rate group, after doing their study and finding things that don't agree, that come out different, it says the single sample potassium argon dates showed a wide variation. A marked variation in age was found in the isochron method using different parent-daughter analysis. Okay, so they're showing that the method itself has some flaws to it. Page 119 of your book, they write, if different methods yield different ages and there are variations within the same method, how can scientists know for sure the age of any rock or the age of the Earth? Some case studies, okay? The Beartooth Mountains, there's geologists believe that this rock unit to be 2,790 million years old, the oldest in the United States. The dating methods show it between 1,520 million years old and 2,620 million years old. That's a difference of 1,100 million years. 1,100 million years difference. Give or take, 1,000 million years. Then you have the Bass Rapids Sill. It's the Grand Canyon rocks, generally accepted age of about 1,070 million years. The results show between 841.5 million and 1,379 million years old. That's a difference this time of only 537.5 million years, so I guess they're getting better. But it still shows huge variation, so which should bring into question how they can claim the exact age of different things when their own methods give such varying degrees. In conclusion, we know that radiometric dating methods are highly unreliable and don't prove that the Earth is old. A helium retention analysis estimates the Earth's age to be between 6,000 plus or minus 2,000 years, which supports the biblical evidence that's given. Make sure you read this material and just keep an open mind when you do. Thanks.